Okay, here's a problem from a past midterm. So we want to find all the values k such that this vector 1k6 is in the span of these two given vectors. And what does it mean to have a vector be in the span of, say, these two vectors? Well, it means you can write that vector as a linear combination of 2, 0, 4, negative 1, 3, 2. So what would that look like, writing 1k6 as a linear combination of these two vectors? Well, you can write 204 times some constant plus negative 132 times some constant, and then that would have to equal 1k6 if you were going to write 1k6 as a linear combination of these two vectors. So here's a general form, and we want to pick a k that makes it so that it's possible to pick some c1 and c2 that would satisfy this equation. If that were true, then 1k6 would be in the span of 204, negative 132. So let me show you something interesting. If we add all the first components, the first entries of each vector together, what do we get? Well, let's distribute the c1 and the c2 in. We get, adding the first entries, we get 2c1 minus c2 equals 1. Now let's add the second component, so we get 0c1 plus 3c2 equals k, whatever we pick k to be. And then adding the third components, we get 4c1 plus 2c2 equals 6. Okay, this is a system of equations, and we know how to solve these. So this is a system of three equations in two unknowns. Now I say two unknowns because technically we have three because we don't know what k is, but we're going to pick k. And then the true unknowns are c1 and c2. All right. Hopefully that didn't confuse you. The point is we know how to solve this. So let's put this system of equations into an augmented matrix. So we have 2, negative 1, 1, 0, 3, k, and 4, 2, 6. All right, here's our augmented matrix. Basically, we want to row reduce to a form that lets us see if we pick a certain k, will the system be consistent or inconsistent? Because the goal is that we pick a k so that this system of equations is consistent. That would mean that there exists a c1 and c2 that satisfies this for that k, which would mean you can write the vector 1k6 as a linear combination of those, which means it's in the span. Okay, so that's the game plan. So let's start row reducing. Okay, I'm gonna get rid of this 4 down here by doing row 3 equals row 3 minus 2 row 1. So we get this. We get 0, and then 2 minus 2 times negative 1 is 4. 6 minus 2 is also 4. Okay, now I'll scale the last row by 1/4. And now I'm going to swap rows 2 and 3, so you'll see why in a second, because I don't want to have to deal with k until the very end. So 2, negative 1, 1, 0, 1, 1, 0, 3k, just swapped rows 2 and 3. And now I'm going to get rid of this 3 here to get it into row echelon form. 2, negative 1, 1, 0, 1, 1, and we'll do row 3 minus 3 times row 2, so we get 0, 0, k minus 3. Okay, so here is our augmented matrix in row echelon form. So remember, we only have to go to row echelon form to see if the system will be consistent. So basically, let's see. If k doesn't equal 3, then what is this entry in this matrix? Well, it's a non-zero entry, which means it's a pivot. And if you remember from the previous video, if we have a pivot in the augmented column, the system's inconsistent. But we want the system to be consistent. We want this to be in the span of these two vectors. We want to be able to pick a c1 and c2 that satisfies this equation. So we want to pick, so first of all, if k doesn't equal 3, then we get a pivot in augmented column. So we get inconsistent. Okay, if we have an inconsistent system, that means this vector equation right here will never be true because it's inconsistent, which means you can't write this as a linear combination of these two vectors, which means it's not in the span of those two vectors. So we want it to be consistent. So what's the only k that would give us no pivot in the augmented column? What's the only k that would make it consistent? Well, if k equals 3, then we would have a row of all zeros at the bottom, and we'd have this be a pivot, and those would be our only pivots, and so it would be consistent. So if k equals 3, it's consistent. So that is our solution. Find all values of k such that 1k6 is in the span of these two vectors, k equals 3. And if you look at that, we have 1, 3, 6. So how can we write that as a linear combination of 2, 0, 4 and -1, 3, 2? We can just add them together. Okay.